I'll
stand
just,
here then.
yeah, okay. We good? Good. All right. Hello, everyone. Welcome to week 4 with UQCS. So with us here today is Nick Lambourne from Canva. Nick was the UQCS president in 2019, and he's now a machine learning engineer at Canva. So without further ado, I will hand it over to Nick.
Thank you. And yeah, thank you for having me. This is it's always nice to be back on what's really home turf. I'm struggling a little bit to get things like, have we ordered the pizza? Did we remember the speaker's mug out of my head, because that used to be my job for many years and many events. But it's always nice to be on the other side, I guess. So yeah, hi, I'm Nick. I'm a machine learning engineer at Canva. I will explain why that's not what it sounds like shortly, but for now, I'll just say that I was a CS student here, and yeah, had a great time being involved with UQCS and helping run events like this one. But I guess sadly, all good things have to come to an end. I did have to graduate sometime. UQ helped me out by giving me an early exit option with CS, but I had experienced sort of life outside progressively through that. Through my time at uni, I'd done an internship at Canva, I'd done another one at Atlassian, and when it came time to decide where I wanted to go, Canva was sort of a no-brainer, but I wasn't sure where I was going to end up. You don't really get to choose so much. You have to go where the business needs people. So I was kind of thrilled when I had the opportunity to go and work with the data platform team that I'd spent a little bit of my internship working with. And that data platform team kind of shifted roles over the years. It became more ML focused, because it was sort of responsible for providing all of this data originally, and the place that data most often ended up going was into ML applications. So I guess we should start at the beginning with what Canva is. Who here has heard of Canva, has thought of working at Canva maybe? Yeah, I've got a few people. For those who haven't seen us around, in Sydney we're on the trams and in the bus stops and stuff, but I don't know what it's been like up here. I made this presentation in Canva. It's sort of one application. It has this massive collection of graphics and assets. You can add your own. You can create well, almost anything. So logos, videos, presentations. The people are doing their resumes in Canva now, which is interesting to see. I've done my last couple of talks for UQCS. The slides have been made in Canva, a couple of logos as well. Canva took a bit of adjusting for me. I grew up in a house with Illustrator and Photoshop because my mum is a graphic designer, and that was just what I was used to. But when I used Canva for during my internship to put together presentations, it was sort of this light bulb moment of like, this is really everything you need to make something attractive and meaningful and impactful all on your own, even without sort of the skills that I saw other people have. And at Canva, as I mentioned, we have this ML application. How many of you have done the ML course here, or have heard of ML, or have played around with something like PyTorch or TensorFlow? Yeah. So it's really just applications of that, and that's I guess a simplification, but there'll be a few simplifications throughout this, and I kind of just wanted to get everyone some exposure to all of the things that surround ML. So we use ML for a bunch of things. This is just a set of examples. Things like personalization. So when you visit the home page and you see like recommendations in terms of templates, recommendations in terms of content. That's ML powered. Even our like help interactions, the order in which you might see help topics presented to you is going to be based on things that you've interacted with, or things that we believe, based on your interactions, you might need. We also use it for like design automation, being able to change the size and have the elements of the design sort of logically relocate themselves to the new size and format. Tracking things like whether customers are likely to stick around. And yeah, image manipulation is a big one. We acquired a company that creates a product that's now fully integrated into Canva that lets you remove the background from your images. And again, this is an application of machine learning. And it's for a lot of people, it's the thing that sort of attracted them to Canva. It was the ability to do this sort of automatically. It's not a perfect solution every time, but it works well enough and often enough that we heard people coming back to Canva as like for this tool. So naturally we did what we could and brought the company into the Canva fold. Now, I mentioned that my team is responsible for doing some part of ML. We have a specialization or a role at Canva called the machine learning engineer. And you can see here up in purple, there's all of these service teams. Now, these service teams have machine learning engineers embedded in them. There might be one, there might be a handful, but they're embedded with the teams making the services that power Canva to augment them with this ML power. And that makes up the vast majority of the machine learning engineers at Canva. And then there's us. We are the ML platform. We sit in a sub-organization called infrastructure, and we are responsible for sort of keeping the lights on, providing the tools and the platforms that are necessary for the rest of the machine learning engineers to do what they do. And we're supported in that, and those embedded machine learning engineers are supported in what they do by another couple of infra teams. I mean, there are lots of infra teams. This is just sort of the ones that are relevant to this discussion. But the data warehouse who store petabytes and petabytes of data from customer interactions, from just all of the data that we consume goes there. It's collected by the product analytics team. And talking to one of their engineers the other week, they hit a new record. I think it was 137,000 pieces of new data coming in per second, which is it's quite phenomenal. And building those kind of services to support that level of traffic is really cool and sometimes quite difficult. And that engineer that I mentioned is also a UQ grad. We interned together. And yeah, he ended up on product analytics and builds these tools to power that kind of interaction as well. So our job as the ML platform team, as I mentioned, is to keep the lights on. And our mission is to make using ML so easy, so just generic, I guess, that it's basically like it's part of the furniture. You sit down on it, you don't really think about the chair as a concrete concept. It's just the thing to sit on. We want the tooling that we make to empower the embedded MLEs to do what they do sort of without thinking about it. We want to make their lives easier and empower what they do. So the question I want to sort of take everyone through today is, how do we take this sort of ML magic and provide it to all of these people, all of these hundreds and thousands and millions of monthly active users is the businessy term, but the fact is that there are oodles of people coming every day and interacting with the site, and for them too, we want ML to feel like, well, something that they don't need to think about, something that enhances their experience but doesn't actually cost them anything in terms of effort. It makes their lives better. how do we serve all these people? How do we take your TensorFlow model or your PyTorch model and serve millions of people or hundreds of thousands of people concurrently? And that's what I want to talk about today. That's this MLOps or ML at scale problem that I want to talk about. So how? Now, I want people to be very careful. When you see a diagram like this, it's a simplification, and there will be lots of simplifications today, and I will point them out where I can. I want you to be mindful of the fact that if this looks easy, if this looks straightforward, it's generally a lie. What it is good at is providing some structure for the direction of this and the way we're going to talk about it. So realistically, we have this process where we're choosing a problem. It's normally a business problem that we want to solve. We are going to gather some data from somewhere. That data warehouse team was probably going to help us out. We're going to do some exploration. We're going to make a model. We're going to train the model. We're going to test, deploy, monitor. It sounds logical, right? But it's the process really is a lot more messy. It's a lot more complicated because at any point you could jump back and decide that your training was insufficient, and the fact that this is a continuous process, and that if you're taking in new data, you might want to just train for the sake of incorporating that new knowledge that you have. So just I guess be mindful, but that's the rough course that we're going to take today. So I sat down with one of our embedded MLEs and asked how they approach this problem, because they have these skills. A lot of them have PhDs in machine learning or AI or statistics. Not all of them. Some of them have gone through an engineering pipeline and have developed those ML skills on their own. But a lot of them are incredibly clever. They come out of these academic environments. How do you take all of that skill and all of those resources and apply them to the problems? How do you pick a problem? So we sat down and we were having a chat, and normally it's led by the product manager for their team. So I mentioned that the embedded MLEs are part of a team. They have engineers, they have product managers, they have designers, front-end people, depending on their role. And it's normally the product manager that's examining sort of the user needs. How does the user interaction get improved by the application of ML? And obviously it's the machine learning engineer's job to say what is and what isn't feasible based on the data that they have and the models that are available. So it's a complicated problem, and it's a back and forth. And it comes down to sort of finding this sweet spot between the user research that the product manager is doing, or the community experts that we have that are going out and meeting with the users and finding out what they need, and then the technical research. So that might come from papers that they read. The embedded MLEs are probably the closest that you get to academia that I've seen, in the sense that they still read papers. They have to be on the cutting edge, and the cutting edge in machine learning tends to come from large corporations like Facebook or research institutions, normally ones that you've heard about. But finding the sweet spot is not easy, and they have to make a lot of sort of small bets. They take an idea, they run with it, and a lot of the time it's not going to work out. But when they do find an application to solve a user problem or even solve internal problems, so stuff like content filtering, finding explicit imagery, is the kind of thing that other companies have been, and Canva is and will continue to automate. Obviously, there's a cost-benefit analysis as well that has to be made. There are certain things that you can't trust to computers, particularly fallible systems. So you have to weigh up where the impact is and or could be, and what the costs might be that go along with that. So once you've decided on this business impact, you have to go about gathering data. Now, the vast majority of machine learning techniques tend towards requiring large amounts of data. I mean, you can train them with less, but normally it's the more the better, to a certain point. There is a diminishing return eventually, but those sources of data, a lot of the time in our use cases, they're coming from things internally. So we have our large collection of images. If we want to, say our task was automatically tagging the photographs that we have with the content. So we want to go through and tag every photo with a dog with the word dog so that it makes it easier for people to search. We can train that. We have the elements for that. We have the metadata for that. The other use cases might be designs. You can get into this cycle, and I'll talk a little bit more about this cycle later on in the talk, but you can use analytics on existing features to design ML features. So when you, for example, go to share, or what used to be called export, your design in Canva, it's the options that you're presented with were generally ordered and filtered by ML. So things that you'd used before, things that we thought you were likely to use, things that we maybe were like things that were new and that we wanted people to try, like Canva can produce static websites. So that might have been prioritized in there if we wanted to get some exposure for it. Now, there is also external data. So a lot of machine learning, particularly when you're in an academic space or if you're in, like you're training yourself on it, takes place on large public data sets. There are issues around using those in a commercial aspect. A lot of them are licensed so that they can't be done, or they don't have a license at all. Pre-trained models, it's a similar thing. It's like there are potential downsides. So if we take this pre-trained model, like GPT-2 is a popular one at the moment, and the follow-on GPT-3 is sort of for text generation. And if we take that, we have to be aware of all of the things that it could spit out. So if explicit material, for instance, had found its way into the training data for GPT-2, because the training set is just so large, we can't just take that model and apply it to a Canva use case without thinking about the consequences of that. We don't want explicit material being generated for our users, particularly when a lot of our users are school children. We have a large education program, and we have to protect those users. So that data, a lot of it's coming from analytics, a lot of it's sort of internally generated, and that internally generated data is going to go into our data warehouse maintained by the data warehouse team. It's now teams because they split, but they're so large and the demand for what they do is high enough to justify these larger teams, because again, it's petabytes of data at the end of the day, and we use a technology called Snowflake in most of the world to store this data, and it allows people to interact with all of that data by SQL queries. So if you've done, I think it's INFS 1200 from memory, it was many years ago for me, but if you've done that, then you have and you can follow a guide, then you have enough skills to interact and retrieve data from our data warehouse. It abstracts away a lot of the complexity that comes along with the sheer size of the data that we have. So once you've got your data, the next question is how do you poke around in that? So exploratory data analysis is a fancy way of saying I'm going to use a Jupyter notebook and get the data and poke around. So we maintain internally hosted cloud notebooks, and people can run them locally to do this kind of exploration. Obviously they can chart things, they can develop preliminary models, and filter out what they need. And generally that involves some processing. It's not normally in the format that you need. You need to do some finagling. Sometimes it's a little bit, sometimes it's a lot. But at the end of the day, you generally produce some kind of repeatable process. And that repeatable process normally takes the form of a script. You might do it in the notebook, but at the end of the day, you've got a Python script that can take that stream of data and do what you need to get it into the format that you want. So this is our first artifact of the day. And we'll talk about this process in terms of artifacts. Again, it's a simplification. We do have things called data.py in our builds, but it can get a little bit more complicated, and we have more sources of data than just Snowflake. So when you're exploring the data, you're normally developing a model at the same time. This is one of those things where the model lied, and normally you're doing it sort of in sequence or in parallel. So again, you're in this environment, you're working your embedded MLE magic, you have your knowledge of the product domain, you have filtered your data down, you've pulled in some sort of machine learning library. Normally we don't tend to do things from scratch if we can help it. Vendors are really good, existing libraries are really good, particularly if they have good testing. So you've pulled in all of that, and you've worked your what is it, Comp 4702 magic. And now we've got two artifacts. You've got a model.py. So you've produced some artifact. We haven't talked about training yet. That's a separate stage. But you do have this artifact, and again, it's a cycle. You do your training, you develop it, you see how it works, and then you adjust based on your findings. So up until this point, you can do all of this independently of the Canva system. You can sit there with the MacBooks that they kindly provide us, anywhere you like, and work away, and you can produce this model, and you can do it locally. You can use whatever editor you like. And if you're doing your training, you can use your laptop as a space heater to boot. I've found that it's quite effective. But we have this other thing, and it's a Canva thing that we inherited from our CTO, who is an ex-Googler, where they have this thing called a monorepo. And the monorepo effectively means that you take all of your production code and you put it in the same place. So how many of you have interacted with Git and GitHub before? Most of you? Yeah, okay, good. We use GitHub. We use the same GitHub repo for all. Again, this is a simplification, but the vast majority of our code lives in this one GitHub repo. It's millions and millions of lines of code. And we make it work using this tool called Bazel. And Bazel's motto is that you would have seen the triangle meme. It's like fast, correct, cheap, pick two. Here you only have two choices and you get to choose two anyway. I mean, there are other downsides, but what we get from using this monorepo is access and the ability to reuse any segment of code, the ability to abstract big chunks of logic, the ability to write things that make our lives easier, to have like a single point of truth for tooling, for linting, for testing, and it makes our lives a lot easier. It's the kind of thing you do have to experience. I've started using Bazel for my own projects, and that's a challenge because we have like a team of I don't know, 10, 15 people whose job it is to make this thing run. But doing it on your own is rough. But the advantage that you get is that it's managing all your dependencies, it's managing all your build artifacts, and you can extend it until the cows come home. You can build rules that produce what you need. And we'll talk a little bit more about that. So I've got a build file here, but it will look better like this. So this is how you make Python in Bazel. It's a little bit different to what you might have seen. If you've used your requirements.txt, it's doing that job. If you've had the joy of working with a Python tool called Poetry, it's doing that job. We have a single collection of dependencies for all of the ML organization and all of the data organization that are pinned at the right versions. So when they use them here, when they do requirement XGBoost or requirement click, it's they're pulling in something that's known, something that's understood, something that we have vetted and decided to include. Outside of this environment, they have the freedom to choose what they like, to build with what they like. If they find something that's of incredible value, then, or even just of value compared to what we have, they can bring it in. They can make a pull request. They can say, I think we should use this instead. And if it is everything that they claim, then it will include it. You can see here, there's also some tools. So this is what I meant, like we've abstracted away things like model trainers, which is just something that we use in ML, but also something like as common as using secrets in AWS is something that's abstracted away. So if we want to abstract anything, we can, and that's, again, it's difficult to communicate effectively, but we can then we can take this Py library called lib and reference it the same way. So this tools build Python lib, we'd refer to it the same way, and then we could use this in any other package inside the monorepo. But what we've done here is we've defined this library, and the only place we're using it is in this Py binary. Now, Python is a fraught place when it comes to producing binaries. It's a lot of work. Sometimes they're not really binaries, but here we've found a rule. Bazel, these functions are called rules, and we found a rule that does what we need it to. It bundles up everything that's required, so all of the lib, all of the requirements. It's going to find all of the source, and it's going to bunch it all together. Then what we're going to do, I mean, this next bit, in terms of function, testing is, I have to be careful how I word this. Testing is optional, but in a industry environment, you're not going to get away with contributing to this monorepo with the high standards that it has for code quality and thoroughness if you haven't tested, at least nominally, the code that you have. So you can see here it's got its own dependencies, but we'll ignore that for the moment. The important parts are this model trainer image and this push. So we've created this, this image, and I'll talk a little bit more about what image means, but it's, if you've ever interacted with Docker, if you've ever run a Docker container, you can think of this as similar to a Docker image. And then we've pushed it up, and I'll also talk about what pushing it up means. So, but first I want to talk about what's included at this point. We've jumped ahead a little bit. We now have this build.bazel that's defining, that's what we just went through. It's defining what's included to the nth degree. We have an entry point, main.py, so that's just if you like creating an application in Python, you'd have main.py, you might use argparse. We use a library called click that allows you to interact with it from the command line. We have our data artifact, we have our trainer. It was model before, but now like we've called it trainer just for consistency. And we've produced a trainer image. And we've done the same thing with the server image. The server image has a lot less stuff in it. At the end of the day, all it's going to do is take something and return ML magic. We'll call it that for the moment. So we've got these two artifacts coming out the other side. Now OCF stands for Open Container Format. That is the format that your Docker images take. You can imagine that the little Docker whale is just sitting inside instead of the letters. But I felt it was, it doesn't matter. Now, when I talked about this, I apologize if it's a bit small, I sort of skipped over what the model trainer image was. Now, it is a Docker image, and it's got a bunch of stuff in it. We have defined this base image. And the base image, again, if you've done more work with Docker, you might have seen things referred to as like Alpine or Ubuntu 2020 or 2004. You need something underneath in order to run your applications. But we decided late last year that we wanted to have that layer of thing that you must have be absolutely as small as possible. So we decided to go down this route of defining what we put in there using a technology called Nix. Now Nix is a lot of things. Nix is an operating system and a package manager and a packaging system. They were apparently not feeling particularly creative when it came to naming things, so they just called it all Nix, and it's led to a lot of confusion. But what it allows you to do is pull in these tools and define an image that is just that, and pretty much nothing else. It fakes as much of an operating system as it needs to run things, but that's about the extent of it. And the advantage is that they're very small, and generally, depending on what you choose to put in them, they're more secure, because big chunks of the operating system you can't change. But for us, it's just a really small layer that goes at the bottom that we could control sort of to a very fine level and include what we needed to. Now, the process of actually determining what the minimum set of things was by trial and error was less fun. But now that it's done, we have images that are sort of 5 times smaller. And we can use them up here as our base image. And then when it spits out, it's going to take our trainer code, our model code, and layer it on top. So that's what we've got. Now, these images, we keep them in a service called Amazon ECR, or Elastic Container Registry, which, again, if you're relying on the Docker metaphor, it's like Docker Hub, where you pull most of your images from publicly, except it's maintained by Amazon and it's private to us. So we put a lot of stuff up there. We put things up there so that if we go to call on an image if we called on it from Docker Hub and Docker Hub was down, or that image went missing or whatever, that would be bad because it would crash this ML workflow, and we can't really afford for that to happen. So we keep our own copies, and we build these images from scratch and keep them in ECR. So we put those images in there, but they're still kind of empty. Like we've got the Python code in there, but they're not going to do anything. I mean, they might run, but they're still a bit limited. So we have to train them somehow. And the way we do that is using another bunch of technology. So we're an AWS shop. We use Amazon's stuff, and they allow you to layer stuff on their stuff. We use technology called Terraform when we want stuff, and we go and grab it. And then we've put this thing called Kubernetes on the top. So when Amazon sells you, or rents you, is probably a more accurate description, a computer, they're selling you sometimes large, sometimes small, but usually like set blocks of computer. And sometimes you want a little bit more fine-grained control, or it might be more cost-effective for you to buy a big computer and split it up into lots of little slices of computer on your own time, which is what we do with Kubernetes. And that allows us to run services, so those cloud notebooks that I mentioned before run on our Kubernetes cluster. And also workflows, which we use to train the images, or train the ML models, like we're going to see now. But first, what is Kubernetes? Kubernetes is very complicated. This is, again, a simplification, but I wanted to try and communicate, because this is becoming more and more popular in the industry, and not just for ML workflows. But normally when you set up a cluster, and that's a big thing, that normally represents several Amazon computers that they've rented you. Those computers normally correspond to nodes, and the nodes themselves run things called pods. Now, pods are an abstraction on compute, so that's your little slice of the computer, and they're normally either running all the time, or they're running just for the sake of a particular job. And you typically don't care if a pod dies. They're set up to be resilient. They're set up to replace themselves. So you define a system as you'd like it to be, and Kubernetes will largely do its best to take that and replicate it in those clusters, on those nodes, by spinning up pods to fulfill the requirements that you've set out for it. And it has this concept of namespaces, and you use namespaces for different contexts of work. So for us, we have admin namespace for the things that run. So what's a good example? Datadog, the service that we use to monitor, should run in the admin namespace. App is where we run the training workflows. It's a little, like, the name is a little bit confusing, but that's how it's currently set up. And the idea is that you can have all of these things running in parallel, and it will just work it out. Like I said, interacting with this is a little bit complicated. We use an also complicated system where we define what we want the Kubernetes to look like, or what the state of it to look like, using a language called JSONet, which is JSON, but you can use comments and write functions, and it's a little bit functional. You can write functions, you can create libraries. It's very extensible, but also a little bit confusing. And at the end of the day, we take it all and it generates JSON, which is, again, the state that we want in Kubernetes. But Kubernetes doesn't take JSON, so, well, it might, but YAML is a little bit easier for humans to read, apparently. So we transform it into YAML, and that's what the state should be. Now, this is all a lot, as I'm realizing now, describing it for the first time. This is a lot to take on, but I'm hoping that what you take away from this is exposure to the tooling. So when you run into problems like this in projects, in your work life, you know what to reach for. It becomes a known unknown, to use some tired political nomenclature. But anyway, we'll keep pushing forward. If you have questions, please let me know. There'll be questions at the end, but I'm happy to be interrupted as well. So once we've got this platform set up, we've got Kubernetes running, we want to be able to run these workflows that are sort of once-off batch training jobs. So we want to take the images that we've got at this point, those artifacts from before, those OCF images, and we want to take them and do something with them. In this case, run the training step, fetch the data, run the training, and spit out whatever we need from that training in order to take the, to shove into that server image and bring that ML magic to the masses. So this is Argo. Argo is another layer of abstraction on top of Kubernetes that facilitates this sort of workflow structure. It allows you to do things like have multiple steps, or split out a process and into components, process them separately, and then stick them back together at the end. So here, it's cutting the workload into 6 pieces and then putting them back together. And this type of structure is called a directed acyclic graph. There's a little piece of trivia that you may or may not ever do anything with, but you may run into that kind of terminology if this is of interest, if this field is of interest to you. So all it means is that the graph proceeds in a direction, there are no cycles, and it's a graph. So a cycle is where it can repeat on itself. So in this case, that would be bad because it would just run forever. But here, we're taking those steps, and in this case, this is doing sort of what we'll talk about next in terms of the training process. Now, again, be wary of simple-looking diagrams. I apologize if it's not simple enough, but you should be wary anyway. In this case, we've got our training data that's going to be fetched by that data.py thing that we wrote before. We're going to run the trainer image in Kubernetes, probably using Argo, and it's going to do its thing, and it's going to spit out this training artifact or model. Model is a loaded term. It could mean lots of things. It could mean one file. It could mean many files. When I was doing automatic speech recognition stuff here at the university, the model looked like a text file with a lot of numbers and letters that didn't really make any sense on its own. But we're taking that output and we're sticking it inside the server image, and we're getting this sort of completed thing. And all it is just layering the data that the server needs to serve its magic into that image, because these images are just layers. If you've written a Docker file, then you know that they're composed of layers, and it's the same thing here. Now, like all good software engineers, I left testing to last. Yo, question.
Sorry, I came back over this already. So the trained models combined with the server image to form a final container image?
Yes.
So like your compiled models are part of the server image?
Yes. That's, again, like whether you need all of the pieces that are produced or just some of them in order to do that serving or the inference step of the machine learning, depends on the type of model that you're dealing with, the library that you're working with, that kind of thing. Normally there's some kind of concrete artifact that is getting taken and shoved into this other image for the purpose of doing the inference. Cool. Testing. Left to last, still very important. I don't want anybody to think that I don't believe that. I spend a lot more of my time when I do write code, and not infrastructure code, but code, writing testing for the code, than actually writing the code itself generally, as a rule. But testing is complicated. Well, it's you do all of the same things when you're testing ML code. When you're back working with your artifacts and you're producing tests, you're doing your unit tests. You're normally doing integration tests, which are sort of that next level of extension. But then you have additional things that you need to take into consideration. So If you've got a machine learning model and it trains automatically once a month on the most recent month of data, what happens if the data starts to change? The data that it's training on, the data that forms the decision-making engine that is your sort of inference at the end of the day. What happens if that data that you're getting has shifted dramatically because, I don't know, someone stopped using a feature, or a large number of people have stopped using a feature, or a feature stopped, we pulled down a feature because no one was using it, or because it was causing problems, or it was causing flaky tests or something. If we take that down and the data changes, what do you do? How do you detect that? That's a complicated question, and that's something that we're actively working on, and it's something that you have to be mindful of. There are outcomes from this as well in terms of business logic, like if your model is non-deterministic, if you don't produce the same results every time, and the people using your application are relying or expecting the output to be the same, what happens when they're disappointed? Do they stop using it? These kinds of things are much harder to test for because you have to do it obliquely. You have to dig into the interaction data. So when someone stops using a feature, or say for instance our background remove started to misperform for some reason, and it was not producing the output that people were expecting, that they'd come to rely on. What happens? Like, how would you test that? Do you there's a confirm and a deny button once you've done the background remove operation? Do you just track people doing deny, or do people want to see what it's like in their presentation before they delete it? So you also need to track deletions of the output object. That kind of stuff is hard, but it's important because you have to, because people will stop using the product or the tool or anything that you're providing them if it starts to fail to meet their expectations. Now, treating this as a linear process is, again, kind of a simplification, kind of a lie. This is continuous. This is iteration ad nauseum to finally get something across the line that that the embedded MLE and their team and the customers are happy with, because we roll these things out and we test them out. We do canary rollouts where a few people will see it, and if their reaction is not good, again, interpreting that response can be difficult, but it's this constant cycle of iteration. So the training process and the going back and forth and adjusting the data, in reality that simple chart at the beginning should have been arrows from every stage to every stage in a giant mess. But I mean, we improve, we get better processes, and we get tooling. So this looks a bit scary. But this is the view of a tool that we've recently taken up called Weights and Biases, and its job is to interact with your model sort of during training and run variations on that training in what's called hyperparameter optimization sweeps. And it just keeps running. And it will tell you which combination of hyperparameters do it. And I mean, traditionally, you might have had to have done this by hand, or you might have changed things sort of more significant to the model, things that you hadn't sort of parameterized out, and we still do that. But this is one way that it's advancing. Obviously, doing this has a cost. Every one of those lines is a training job. If your training job takes 12 hours, how many lines, how many trees is that? So again, something to keep in mind, and something that we do keep in mind. So we're approaching the final stage, and we use a tool. Once we've got those images, you can see here that image with the little artifact inside that it needs to do its job. We use a tool called SageMaker. SageMaker, again, is another Amazon product, and it takes the image and some configuration values and effectively spins up these these EC2 instances, running the server with all of this stuff inside it and responding to requests. Now, it's again a little messy, but that's up the top there, that's a load balancer. Now, there might be one or there might be many, or depending on your configuration, it might be a single instance, but the job of SageMaker, at least the part of SageMaker that we use, is to abstract away this problem. We give it the image, configuration, and it sets up this system where we've got the compute that we need with the images that we need and the ability to serve. And then we can do the last step, which is inference. So normally this looks a bit confusing, but well, in fact, in most cases or all cases, the ML interaction isn't with the user directly. So it's normally another Canva service. So Canva, as you might know it, is this web application. Behind this web application, made of thousands and thousands of lines of TypeScript, is back-end services. It's normally those back-end services that I've kind of abstracted out here that are making the request to this setup, this SageMaker setup. And they communicate, they contact the load balancer. The load balancer says, hey, I can connect you with one of these instances, and the instances themselves take in the input. So it might be a user ID, it might be an image that they want to remove the background from. And they do the operation, and they return it, and the load balancer passes it back up to the service, the back-end service, and the back-end service says, hey, front-end, like, here's the thing you asked for. And a lot of the time, people aren't asking for it, it's just happening. So there are many, many interactions happening while you're using the application that you don't think about or don't see. I mean, if you go into your developer tools, you'll see the requests being made, but again, it's kind of hard to piece together what those are. But a lot of those requests are going to be ML content, ML provided content, ML manipulated content that provide that experience that you've come to understand as Canva. Yeah. And again, something that is very important is minimally covered here because I know that we're on a timeline. But monitoring is a huge part of what facilitates Canva. Again, it's a massive source of the data that we use for ML models in training. And you can create this cycle, this data flywheel where the users are interacting with the product, they produce data, and you can use that data to make the product better. And we do sort of use that cycle. And again, we need that cycle to monitor. Monitoring takes the form of logging. So most of you have seen logging output. We ship all of ours to a vendor and they produce it in the nice fancy UI. Or dashboards telling you how often something's been used. Again, this is all something you have to set up. You don't get any of it for free. But once it's there, it can provide insight into how something's being used, if something's being used. I mean, it's always disappointing to get to the stage where you've gone through this whole process and come out the other side and no one's using the tool. Sometimes that's an advertising problem, sometimes that's misplacing the user need problem. But we don't, it's not a blame game, it's a move on and find the next application game. So that's it. That's the process as I wanted to talk about it. There's a little add-on at the bottom, but we do also have these, which I have been asked to talk about. So I was an intern. There is a I'm sure cringeworthy video of me and Jack talking about our intern experiences at Canva. We had a great time, and I don't know. It's difficult. It's a good taste of what Canva is like. It's difficult to describe what that's like without you being there. If you're ever in Sydney, hit me up. You can come for lunch under less COVID-y circumstances. But if you have questions about what Canva life is like, come and let me know. So in addition to the 12-week internships in Sydney, we also have a grad program for final year students, and there are, if you're graduating mid-year, you haven't lined anything up, then we have roles starting in September or earlier that are open now. 2023 grad roles, I think, open in June. Those internships are open now. And yeah, if you have any questions about those, again, I've been both an intern and a grad now, so I can hopefully answer the questions that you have. The interview process is something that I get asked about a lot. This is sort of the most up-to-date information that I could get of an evolving process from one of the people doing the evolving. So once you apply, you'll get sent a code screen through a platform like HackerRank. You'll talk to one of our recruiters, commonly Dan, on the phone. That process is normally a couple of technical questions to gauge sort of, have you done second year object-oriented programming? The code interview, you only do one if you're going for an internship, and then you'll also do a short SCL, which used to be called values interview. It's behavioral interviews. Don't tell anyone I said that. I mean, the people that you'll interact with in this process are generally friendly, and I've done a lot of interviews over the years and had some very unfriendly interviewers, but thankfully none of them were at Canva. And yeah, so if that all works out, if they like what you had to say, you'll get sent an offer. Obviously, if you're a grad, you'll do 3 code interviews. I think they're 45 to 50 minutes long, but you'll normally get a chance to have a chat as well. So that's the process. It seems like a lot. It's reasonably consistent with the Sydney tech scene and or what limited exposure I've had to America. Any questions? Yeah.
Disappointed that you didn't really go into like what models or algorithms you use exactly though. It's more like an infrastructure talk really.
Yes, I mean, I'm not an embedded MLE, so my exposure to that is limited. I've dropped out of ML courses more times than I've completed them, so there's that.
Maybe probably what you were put off by Marcus, like.
No. To be fair, it was UNSW, and I was more just exhausted than not engaged by the material. Any other questions? Yes.
Obviously, you talked a lot, and there's a lot here for I don't know how many first year or experience. Is there anything that you specifically want people to take away as things that people should start messing around with to get a better taste of what we talked about?
Yeah, I mean, if you want to get started, there's no better place than the those intro ML tutorials that are provided by the vendors, the PyTorch and the TensorFlow docs. I mean, you get started. Everyone's done the optical character recognition TensorFlow thing. Once you get beyond that, you can start playing around with the I guess more complicated workflows, more complicated models. I mean, at the end of the day, you do have to, if you want to do the ML model development stuff and not this infra stuff, and I apologize if anyone was sort of misled by the talk title or the description, but if that's the stuff that you want to do, then you do have to work through the theory, and the theory is a lot of statistics, a lot of linear algebra, but it's you can get started with those tutorials. In terms of playing with the infrastructure stuff, I would recommend playing with it sort of in isolation. Taking on this entire stack at one time is a lot. It's a lot as a day job. But generally, like at least in my experience, being exposed to these tools, you're given like the you learn that this is a better way of doing things from the start. So organizing your infrastructure with Terraform, once you know Terraform, doing your builds with Bazel, doing things by creating artifacts is just a better way. And you pick that up piece by piece. And again, I wouldn't recommend to anybody, unless you're doing it for an internship or just you want it to be hardcore, take it one step at a time. Play with Kubernetes. I know like there's actually a really good UQCS talk that Neil Ashford gave a couple of years ago. I'm fairly certain was recorded, but I can't confirm. I'm sure we could get him to dig out the slides. But the tooling is kind of fun in and of itself. And most of it is well documented. Bazel's perhaps the exception to that. Yeah, question up the back.
It's a really great tool. I feel like you're suffering with Bazel. I've had to play around with it. It's been getting better over time. It's still third-party dependencies, kind of maybe not too widely known sometimes.
Yeah, it's a struggle, and it a lot of it feels wrong to start with. But once it works so well. But yeah, the struggle. I've been playing with Rust personally, and playing with rules Rust was a bit of a nightmare. But again, once it works, and it's a fun time. Yeah.
So,
sorry.
That was the sound. My actual question was to do with programming languages. You mentioned Rust, but I know that some ML pipelines will do the training in Python, but they'll do the actual serving and deployment in a language like C++, the word more into something like TensorFlow serving. Do you make use of any of that for scalability?
At this stage, that part of the pipeline hasn't been the blocker. We only one of our models has sort of hit the threshold of the performance that you see with Flask. The Python serving, like the sort of bare bones Python serving framework, and we're looking at other mitigations for that, sort of working with more async frameworks, but not necessarily a language change. As much as we'd like to use Python, Python is a struggle in industry. Has a lot of shortcomings that you don't really realize as an individual. But then when you, and not just on a performance standpoint either, things like producing binaries and that kind of thing.
Plus the language like updates every year, pretty much.
Yeah, well, I mean that's less of a, like we've gotten to the point where we're reasonably happy updating like on the same cadence that they do, but just other struggles, and yeah, as much as we'd like to use stuff, and there is support. The most of those ML tools, TensorFlow, PyTorch, are written in C++, and then have bindings in Python or bindings in Java. I don't know. We can daydream, but at the end of the day, it's got to be an approachability question for all the MLEs that we've got to support.
Yep. What was the project you worked on when you were an intern?
I built a transpiler to turn Bash code into Python. Well, I mean, it was set up so that you write the generator, so the last part of the pipeline, and it could be any language you like. It was sort of, there's a lot of, well, at the time there was a lot of bash in the infrastructure group inside Canva, and writing good bash is hard. There aren't a lot of people that know best practice in bash. It's very portable, but it's not very readable. So we were looking at a way to, it was a moonshot project. And at the end of the day, it worked, but there were like limitations, and rolling it out to 200,000 lines of code was not something that an intern could achieve while I was there. They are chasing me to open source it though, because Canva has an open source thing coming. Well, if it isn't out now, then it'll be coming soon. Yep.
I see there's a lot of layers before the ML, like whatever the model produces, up to the end users. So like there's like backend and then like there's front end and then it gets released. So are there any like, I was wondering if there are any like direct exposures, like security vulnerabilities that the ML that your team has to consider?
It's not in my experience. I mean, I've only been there a year as a grad, but nothing that I've seen. Most of the big, like, I guess, problems that we've seen security-wise have come through like really widespread Java libraries. That have
It's obligatory at this point, pretty much.
Oh no, I mean it's like, again, it's just us responding to news. It's not necessarily like as far as I'm aware, it hasn't been us actually having a security incident as a result. I mean, they call it an incident internally, so there's impetus and stuff, and they go around and clean it up. But at the end of the day, it's I don't know, keeping up with best practice, because log4j or whatever is busted. Yeah.
That also, like, that previous question also like made me think about sort of like training data poisoning and stuff like that. And you mentioned in the talk there's like you got to protect like stuff that doesn't like show explicit like content or images and stuff like that though. Like how do you combat that? Something like that.
I mean, again, most of it is like coming from internally. We have the ability to sort of go through and filter it. We're incredibly mindful and proactive when it comes to personally identifiable information. So all of that is stripped out before any, well, nobody sees it. Nobody sees like the contents of your designs on Canva. No one's seeing that internally. It's all anonymized. It's all stripped out. And I guess that helps, because obviously if we were feeding that kind of content, like I know I've made Canva presentations with content that I wouldn't want to feed into any ML model. But it's a hard problem, and at the end of the day, we take advantage of a lot of manual verification. Like we have people that their job is that, and obviously we try to augment them, but at the end of the day, like it's worth the investment in people power to fix that. Yeah.
The fact, as a follow-on to that, the fact that you use an explicit training process for things and have it's scripted in a pipeline to do training is a useful mitigation for that. I'd assume that you've got things hooked into your content moderation pipeline, so if something gets flagged and removed, then it's also removed from training sets the next time the training runs through.
Yeah, absolutely. It's and I mean it's also that verification step generally takes place before we have access to it as well. So it's I mean it is something that we're mindful of, but again not something that we've come up against the consequences of, at least to my knowledge. Yep.
Just to get a little bit more of an easier question. Having gone through the intern process, I'm assuming it's pretty similar to the grad process. Would you, like, what sort of content or say areas